Good afternoon. My name is William Roberts, and I am a senior engineer at Shell Games. Shell Games is based in Pittsburgh, Pennsylvania, and we are primarily focused on transformational games. We see transformational games as games that better the player by the end of the game. Examples of transformational games that we have done is Play Forward, Elm Street Stories, and the World of Lexica. At Shell Games, we use a number of different technologies. One of those technologies we use is Unity. I have been involved in a number of Unity games, one of which is Mechatars. Another is Intercube, which was just recently released on the Ouya platform. And our latest game, the World of Lexica. So to give you an overview of my discussion today, we will be talking about custom build processes. If you saw me at the Unite 11 conference in San Francisco, I gave you a high-level overview of how we build large-scale projects. Today, I'm going to take a deeper dive into how exactly that build process works. The first thing we're going to discuss is how we extend our code build process. After which, I'm going to discuss automating the building of Unity 3D projects. I'm going to show you guys a demonstration of all the things we learned throughout the discussion. And finally, I'm going to follow up with a conclusion. So let's start with extending the code build process. One thing I will note before proceeding on is that I'm going to show a lot of code samples. I know a lot of people will be frantically writing down stuff. I do not have a lot of time, so I may have to skip through things quickly. The very last slide of my show will have a URL to both the demo source code and the slides. So at Shell Games, we often have large-scale projects. Sometimes in the past, we've had problems with Unity projects where they were so big, it would crash the Unity editor. Therefore, we had to split up the Unity projects into multiple Unity projects. When we do so, we often have code that is shared between each of the projects. And we don't want to have to copy the source code into each one of them. So we developed a code process where we copy each of them into each of the Unity projects. Basically, this happens in Visual Studio during compilation time. A post-build process kicks off, and each DLL is then copied into the Unity project. So the benefits of this approach is that code can easily be reused across many different projects. You can build framework DLLs or assemblies and share them across each of the projects. It also gives you greater control of what code makes it into the project. You could have code that is used for debugging only, that for your release builds, you have it excluded. A big negative of this approach is that this is kind of outside of the Unity editor. We're going against what Unity normally does. When you make source code changes in Unity, it'll detect those changes, rebuild the code for you automatically, and have it ready. This adds an extra step of you having to build the code external to the Unity project. Therefore, there is an extra layer of complexity. It's just one more step that can go wrong. So how do we copy the DLLs into the Unity projects? There's actually several ways to do this. One of them is Visual Studio post-build events. Another is mono-develop custom commands. You could also utilize MSBuild built-in tasks. And finally, you could even create your own custom tasks, to name a few options. So to start, we're going to talk about Visual Studio post-build events. Visual Studio post-build events are essentially Windows batch files that are executed before and or after a build completes. By default, mono-develop out of the box will not execute the post-build events. However, you can actually enable support for it. There's an option that's compile projects using MSBuild XBuild. I'm not going to talk about that right now, but a couple slides from now, I'll actually show you where and how to do that. A big pro of this approach is that you can easily invoke commands and other external applications before and after the build. However, it's not cross-platform independent. Even though you've enabled that option to allow it to work in mono-develop, Mono will, under the hood, will treat the build events as shell scripts on OS X, Unix, and Linux, and batch files on Windows. Therefore, if you have any batch file syntax, it's going to be an error on OS X. Additionally, it does not provide good feedback within the IDE about errors and script issues. So another alternative is mono-develop custom commands. It's mono-develop's alternative to the post-process commands. Basically, you provide a sequential list of events that are executed. A big pro to this is it is cross-platform. You can set it up in a way that will work in Visual Studio, on MonoDevelop, and on MonoDevelop on OS X, Unix, and Linux. However, the commands are only executed by MonoDevelop. Visual Studio, MSBuild, and XBuild will not execute these events. And as an additional thing, it does not provide good feedback once again. Also, because there's sequentially executing events, if you need any complex logic based on your build setup, you can't do it. It's going to execute each one individually. You have to leave it at the script layer. So another alternative is MSBuild built-in tasks. This is a step up as we're more tightly coupled and integrated with the build process. Visual Studio projects are just XML files under the hood. This includes Visual Basic projects, C# projects, and a lot of other ones. These XML files are also known as MSBuild scripts. Since they're just XML, it's possible to edit these scripts in Notepad. You just open it up and you can start inserting your own custom logic. They have what's called as targets within the MSBuild projects. Two handy ones that are predefined that you can override and insert your own logic are the before build and after build targets. We use the after build targets to copy our DLLs over. So MSBuild provides a number of built-in helper tasks, such as the copy task. As you can see on the slide, I have a link to a complete task list. I'll let you have the link at the end of the slide, so don't worry about writing it down now. MonoDevelop supports most of the built-in tasks. However, you must enable the MSBuild support via the options dialog. So let's take a look at how to do that now. In MonoDevelop, from the main menu, you're going to navigate to Tools and then Options. That will display the options dialog that you see on the slide. On the left-hand side, you're going to expand the projects settings, and then you're going to locate Build. Once selected, you will have the Build options. Locate the compile projects using MSBuild/XBuild option and check it. Click OK to enable the option. What this does is this disables the MonoDevelop internal compiler, and it will start using the XBuild engine under the hood. So the pros to this is that XBuild will automatically handle the conversion of relative Windows file paths to Unix-style paths on OS X. This lets us create a copy process that will work on both Windows and OS X should we be jumping between the systems. It also has fairly consistent behavior across the platforms. The main con is that we may not have the ability needed out of the box. So this is where custom tasks come in. For instance, we may want to detect and copy editor assemblies into a directory named editor within the Unity project. To give us greater flexibility, I'm going to walk us through how to create a custom task now. To start, we need to create a Visual Studio class library project. Note that the project's target framework must be set to .NET 2.0 in order for the task to work with Mono's XBuild. Mono currently does not support newer versions of the MSBuild framework, so you must set it to .NET 2.0. If you don't and you run the task, you'll get an exception that is raised. So proceeding on, we have the new Visual Studio class library project that we just built. So now we must reference the MSBuild framework. So you'll reference Microsoft.build.framework and Microsoft.build.utilities. So this is an example of how to create a custom task. This is just bare bones, just to get the point across of what you would want to do. So we create a custom class named example task, which inherits from task. As you can see, there is a single property named failure text. Failure text has the required attribute attached to it. The required attribute means that failure text must be specified in the MSBuild XML file or there will be a build error. We override the execute method to insert our own custom logic. When MSBuild hits our task, it's going to execute this method to do our task. In this example, I show how to log an error, and then I return false to indicate that the task has failed. So how do we integrate this task into our MSBuild projects? So we're going to open up the Visual Studio project that we want to insert this into in Notepad. Using the using task, we can include the DLL that we built with our custom task. There's two ways to include the DLL. One is using the assembly file attribute. The assembly file attribute lets us specify either a relative or full path to the DLL. We can also use the assembly name to specify just the assembly name. However, the assembly must be located either relative to the tool using MSBuild or the Visual Studio project. For each task, you will have a using task. So you'll see that we name the task name, the example task we just created. So just as an example, I override the after build target, and I insert our example task. So our build does not fail. I specified the failure text. You'll see it says text sent from MSBuild script. So what does that look like when we run it in Visual Studio and MonoDevelop? So at the top, you'll see this is the output that we get in Visual Studio, and bottom, you'll see that there's similar output in MonoDevelop. This gives us greater flexibility of reporting errors and messaging to the IDEs. So some ideas for custom tasks. You could utilize MonoCSIL for a number of different things, including inspecting the assembly prior to copying it over. One thing that we do at Shell Games is that we ensure when we copy each assembly into each Unity project that the assembly has the same GUID for the meta file in each project. The reason for this is if you copy the assembly over, let Unity generate the meta file in each of the projects, you will then have assets hooked up expecting a different GUID. This is very problematic when you export assets from one project and then import it into another. When you do this, if the GUIDs don't match across all the projects, the assets will unhook the scripts. Another thing that we do is in Visual Studio, we detect if you're running under Mono or the Microsoft.NET framework. If you're running under Mono, we use mono.csil to generate MDB files. Even though we may not be using the Mono debugger, this is still helpful because if the MDB files exist in the project, when an exception is raised in in Unity, you'll get a full stack trace that includes file names and also line numbers within your source code files. Additional to this, we also inspect the assemblies to see if they inherit from the Unity editor assembly. If they inherit from the Unity editor assembly, we then copy them into a directory named editor. As you know, all editor scripts must exist in this directory. So some other things you could potentially do that we don't currently do is you could scan the assemblies for potential runtime issues on iOS. If any of you have done any development on iOS, you know that some things like events will not work, and if you build a project, you don't know that's a problem until you run the game, which can be costly in iteration time. You could possibly build in a process to automate this. Also, you could use this whole process to insert special profiling code based on current build settings. So next up, we're going to talk about automating the building of Unity 3D projects. So there's a couple different options for automating the process. You could build a custom command line application, you could build a GUI application, or you could integrate our framework directly into a third-party application, such as cruisecontrol.net. Now, one thing is if you build a GUI application, I would highly recommend avoiding the Windows Forms API, as in Mono, there's a large number of problems, and it gets even worse when you run on OS X. So you should definitely avoid this if you're going to be trying to build the project cross-platform. Instead, I would highly recommend using the GDK Sharp framework instead. So there's a couple different ways to build Visual Studio projects. So this is going to be the first step in our build process. We'll build our code, and then we'll launch Unity and build the projects. The two ways that you can build the code is using command line tools. Microsoft.NET Framework provides MSBuild EXE, and Mono provides XBuild. Both work very similar from the command line. Additionally, you can actually programmatically embed MSBuild into your process. Both Mono and the official Microsoft.NET Framework support the Microsoft.build.buildEngine API. Mono currently has support for both MSBuild 2.0 and 3.5. So let's take a look how we embed this. So one of the first things you may want to do is customize how the log output works. MSBuild includes a number of loggers already in there, so if you don't want to have to mess around with this, you don't have to. But for example's sake, I'll show how to implement a custom one. First, you implement the iLogger class, or the iLogger interface. The iLogger interface has a method called initialize. It gets past an event source that has a number of event handlers that you can listen for. By listening on these, we can write out the information to the log file. You'll also notice that there's a shutdown method and a property called verbosity and parameters. The verbosity property will be set during the build process, and the parameters will also. You can use the shutdown method to close any streams that you may open for file I/O. So how do we embed the MSBuild engine into our project? First, we'll create an instance of the engine class. Next, we'll register a logger. As you can see in my example, I registered the custom logger that we just created. Then we'll build the MSBuild project. You can either build a Visual Studio solution file, or you can do the project files themselves, such as a C# or VB project. Once you specify what to build, you'll specify which build target to build. In this case, I am building the build target, which will build all the code. You can also specify an array of strings, which will let you specify one or more targets to build. So you could specify clean and then build, which would clean the code first and build. Now, these are using the built-in targets that are defined. However, you can make your own targets up and specify them. The method will return true if the build succeeds and false otherwise. And the final thing we want to do is unregister all loggers. This is important because loggers that are using file I/O that rely on the shutdown method to close the streams will get their shutdown methods called during the unregister all loggers. Therefore, you want to make sure to call it all the time. So if you're using MSBuild 3.5, we need to do a little bit of additional work. We need to add an assembly binding to the app config file. This is because MSBuild is using the entity framework under the hood. The entity framework links to both MSBuild 2.0 and 3.5. If you don't specify that you're using the MSBuild 3.5 version, you'll get an exception stating that it does not know which version of the .NET framework to link against. So now to the part of automating Unity. So this is where everything starts coming together. We've built our code. Now we're going to launch Unity and communicate to it to get it to build our projects. You can use the process class to launch Unity on both Windows and OS X. Unity has a number of command line arguments that you can pass to it. If you've not explored this before, I have a link up here pointing to the documentation on the command line arguments. So I'm going to talk about 4 of the most important ones that we use in our build process. The first one is batch mode. This tells Unity to run without a visible user interface. This lets Unity run in the background without any user input needed. We also use the quit argument. Once Unity is done processing any commands, this tells Unity that it should shut down immediately. The project path argument specifies the project that should be loaded. You will always need this in order to get the code loaded. And finally, we use execute method. Execute method is a method that will be executed immediately after Unity loads a project and then imports all the assets. This method must be a static method that is parameterless. If your class containing the method is within a namespace, you will need to specify the namespace dot the class name dot the method name. So to show an example of how this works, we start by creating a process start info instance. We specify the file name to the Unity editor. In this case, my example is on a 32-bit version of Windows, and we're pointing to the Unity instance at the default path. We then specify the arguments just went over. You'll see down at the make arguments method that I fill in the project path and execute the method. Now we create a process instance and specify the start info. The start method is what will start up the Unity editor. For example purposes, we call wait for exit. This will block the process until Unity terminates. Unity will return an exit code that we can then check for. In this case, if Unity returns 0, we'll print out the build was successful. So passing arguments to Unity. It is possible to pass your own arguments to Unity. If you pass something that Unity doesn't understand and can't process on its own, it will just ignore it. In order for you to retrieve these, you can use the environment class on the Unity side. Both the command line property and the get command line args method will be populated with the command line arguments that were passed in. So a real quick example of how this works, I use the command line property here just to return a string, and hypothetically, I'm searching the string for the force Android switch, which I specified. If that's set, then I force the set active target to Android. Another example that I'm showing here is with the exit codes. You can actually return your own exit codes using the editor application class. If the code succeeds in this case, I return 0. If an exception is raised in the code, I return -1. So it's possible to use interprocess communication to send data between the two applications. This is useful for displaying progress of the build within the launcher application. So some possibilities for this, you could use name pipes, you could use file I/O, or you could use sockets. One thing that I can say about named pipes is that the named pipe classes in .NET are not fully implemented on OS X. So if you're building something cross-platform, you should definitely avoid it. So now we're going to go ahead and switch over to doing a demonstration. So just to show file structure real quick of the demo project, if you download it yourself, there will be a source directory and an example project. And I also have a README that you can read. There's a little bit of configuration you have to do to set up and point the project to your Unity installation. Note that the example will work on both Windows and OS X. The source code directory contains the source code for the project. If you open up the solution and build it, it'll create the bin directory that you saw back at the root. The example project actually illustrates how at Shell Games we structure our projects. You'll see we have a code directory. This has all the Visual Studio projects, and then we have a Unity directory which has all the Unity projects that we're going to build. In this example, I actually utilized MSBuild to specify the build order steps that we'll build. The MSBuild project builds the code, and then it uses a custom task to launch Unity as a background process, and it uses socket I/O to communicate between the two. When the code builds, we have an additional task, a copy task, that will copy the DLLs that are outputted from the code into each of the Unity projects. So just to show this real quick, I have a Visual Studio C# 2010 Express Edition. You'll notice that there's some folders unavailable. I have the documentation linked, and the MSBuild projects are linked under this one. The Express Edition won't show this, but the Pro version will, and MondeVelop and Xamarin Studio will all show those. So just to illustrate, I have a breakpoint at the end so we can see it. It's a simple command line application. I wanted to keep this as simple as possible so that it was easy to follow. And we'll go ahead and run it. So it just built the code, and now we're waiting for the Unity editor process to connect. Once it connects, it'll print out that it's connected, and we'll get some text back here. So what happened here after the client connected, Unity sent over the socket here, hello from Unity. The DLL that we built during the code compilation process, we then call a static method on that and send that back over the wire. So this is hello from the copied assembly. And then just to demonstrate passing your own command line options, I had a switch that I specified, and it's echoing out the option that it would use, building with target web player. Just to dive in a little further, because I still have a little bit of time here. If we expand the MSBuild extensions here, you'll see there's a copy task and a Unity task. The copy task is used by the code project. When it builds, the copy process will copy over. Now, I don't go into all the details about creating the MDBs or checking if it's an editor. I have a to-do in here that says if you like this example and want to move on, you can fill that in. And then here, if we open up the Unity task, you can see that we started up using the process class, and down below, you can see where we create our little network server to communicate back and forth between the two. So switching back over to the slideshow here. So in conclusion today, you've learned a little bit about how Shell Games has their automation of their Unity projects set up. We have this process set up so that anyone on the team can build all the code and all the projects. That includes designers, artists, producers, anyone on the team to do it. We then took this process also and set it up with a continuous integration server. So every night at midnight, we have a new build kicked off. Team members can kick off this build and have new builds created at will. And this lets everyone on the team continually be able to create a build. So next up is Ryan Hipple. He's going to be talking about empowering content creators. In our new game, The World of Lexica, we have what's called the vignette system. It's almost BioWare-esque interactive cutscene dialogue system that we've built. And he's going to talk a lot about our character creator. So thank you very much for attending. This is the URL where you can find the slides. Note that I also have my Unite 2011 slides up there as well, and there's a link to the video for it as well. I think we have a little bit of time for a couple questions. If you'd like to ask a question, stand up to the microphone in the center here. Hey, can you put my slide back up real quick? Some people are still trying to write down the URL. Thank you.
Do you have a way of kicking off that build process based on check-ins? So like doing a continuous deployment?
We are currently not doing it, but you could do it with a continuous integration server. Like, are you talking about on the actual build server or locally?
On the build server.
On the build server, yeah, it does check for, we have it timed because it takes so long to build. We don't have it continuously keep going because there's some times where we do like to kick them off. We have a total of 5 build servers for our current project. And we have each build server doing a different configuration because it takes so long to build the game. Can you come over to the microphone so everyone can hear?
So how do your artists and designers interact with this system? Do they have a tool on their desktop that they use to basically kick off the build locally after pulling down from your repository? Or is that process streamlined more?
Yeah, we have it a lot more streamlined than this. We actually have a GUI interface that the users can use, and it's simple as clicking. We have a bat file that launches the GUI application, and they just click a single button, and it takes care of building everything for them. Anyone else?
Hey,
Hi.
you said you had 5 build machines.
Yes.
How long does each build normally take for your projects then?
Right now, it takes anywhere from 2 to 3 hours.
Oh, okay. And do you have one build machine doing multiple builds?
We have builds split across machines, so we'll have like a debug build on one, a release build on another, and we have a couple different projects all going at the same time.
But I mean, on a single build machine, are you trying to do like multiple builds on that machine? Because like what we do is we have a build machine, but it actually has 2 Unity projects building at the same time, because Unity doesn't take up the full processing power.
Sure. Currently, we're only doing one project at a time when it builds.
Oh, okay. Cool. I was just curious, that's all.
Hi. So how do your programmers, when they're writing the code, are they working inside Unity, or are they just editing the code and then building it?
We're doing it all in Visual Studio, so the MSBuild task, when you open up the code project and build, it copies automatically over to Unity, and then we can hit the play button.
Okay.
Yeah, actually, the project, if you download it, if you go into the example project, the code directory, there will be a solution file. If you open that up and build in Visual Studio, you'll see that it copies over into the Unity project.
Okay, thanks.
The last question made me wonder, are you using Unity VS to build in Visual Studio, or are you bypassing that completely with your own solution?
So we've actually looked at Unity VS, and because of our project setup, it didn't play very nice with Unity VS, and we've been in talks with the Unity VS team to try to get them to accommodate our setup. So not currently.
So with this system, you can't debug like your code as it runs in the Unity editor?
You could switch over to MonoDevelop. We support both building in Visual Studio and MonoDevelop, but we prefer to use Visual Studio where we can. We have pro licenses for the whole team. Anyone else? It looks like I'm out of time, so thank you very much. I'm going to switch over to Ryan Hipple now.